This is the Propeller Platform Logic Analyzer, or the PPLA. It's a digital logic analyzer for the Propeller platform, and it's made by the shop at Wulfden. I just got my hands on a bare board. They should have a kit available fairly shortly. The purpose of a digital logic analyzer is to track and record the states of all the pins in your circuit or on your propeller platform to help you in debugging and understanding what's going on. And there's a companion PC application called the Propeller that lets you set mask, trigger, and arm states. It's pretty cool, pretty sophisticated. We'll take a look at it. I've set up a little demo circuit, so on the bottom I'll put the Propeller, in the middle I'll put a propeller platform, and then on top I have just set up a little infrared detector which we'll use to demonstrate the Propeller software. This is the Propeller software, and you just download it and unzip it. There's no install or anything. And the circuit we're testing is just a simple IR detector, which I'm going to fire off with my TV remote so we can capture the IR codes on my remote. On the bottom I have the PPLA, bottom of the stack, and that's connected to my computer through a prop plug. In the middle I have a propeller platform USB. Right now it's pretty much just a power supply, but if it were doing something or signaling another chip or whatever, we can use the PPLA to watch that. And on top I have a Propeller with my IR detector. So in the Propeller you have kind of three views. You have take a snapshot, capture continuously, or capture with arm and trigger. We'll do a continuous capture to start with. And this is the state of all 32 I/O on a continuous basis. Not really that useful unless your project is using all 32 I/O. Right? Most things just use a few I/O. Maybe it's an SPI interface with 4 or I2C, whatever it is. So the first thing I do is I change the show here. You drop this down and you can say, what pins do I want to actively monitor? Hit this to flip them all, and then we'll turn on pin 6 because that's the pin where the IR detector is connected. So pin 6 is high. The reason why it's high is the IR detector is high when there's no IR detected, and it goes low when there is an infrared signal detected. If I grab my remote right now and I hit a command like volume plus, it'll capture that, but it'll move off the screen because it's being captured continuously too quickly for us to study or analyze. So what we do about that is we use the capture with arm and trigger rules. The way the arm and trigger rules work is first you define what pins are going to be part of the rule. And the rule is just a condition, right? When pin 6 is low, pin 7 is high, pin 8 is low, whatever it is. So if a condition requires pins 6, 7, and 8, you'd select those 3 pins in the mask. Then you set the arm. The way the arm works is, you fire a missile. First, it's armed, and then it's fired, right? So before the analyzer looks for the trigger event, it waits for the arm event. In this case, the arm event and the trigger event are the same. But if your circuit is more complicated, you may want to say, first wait till this pin goes high, right? Maybe it's a clock select, and then wait till the first clock signal, and then start recording, right? So that's the purpose of the arm and trigger. This is a pretty simple demonstration, so arm and trigger are the same. And the arm event is when pin 6 goes low, it's already set. And the trigger event is the same, pin 6 goes low. So start recording when pin 6 goes low. Hit this button, capture with arm and trigger rules, and when I hit the button on the remote here, you see that the code has been captured. So you can zoom in by clicking here. You can pan. You can analyze, study it, that kind of stuff, right? So another thing which I think is pretty cool on this too, you can group. So we're only analyzing one pin here, but if we were analyzing more, we can group the pins, color code them, and it really helps in understanding the interface, what's going low when, how long it is going low and how long it should be going low. It's a pretty cool tool. I used a lot more than the oscilloscope because I do more stuff in digital than I do in analog, and the digital logic analyzer is the perfect tool to understand the digital signals. So a lot of fun. It's free. The software is free, and it's very easy to use.